There are 5 properties for exponent rules. So the first one that we have is when 0 is an exponent. We'll talk about these more in a little bit. The second one is when we have a negative exponent. The third is a product of powers. And then the fourth one is quotient of powers. And the last one is when you have a power to a power. So this video is going to go over all 5 of these properties one by one and kind of explain to you in detail what each of these mean. So I'm going to leave the top 2 for the last, and I'm going to start with the product of powers. So product of powers means that we are having a base, let's say m, so a base with an exponent. Product means that we're being multiplied by something. So let's say another base with an exponent of 2. And we have to figure out what these would equal, or we're going to simplify them. So if I were to expand this out, that little exponent means how many times that base is being multiplied by itself. So m would be multiplied by itself 3 times. This m would be multiplied by itself twice, so 2 times. And I'd still have this multiplication dot to represent between those two. So once I expand that out, I can see that I have 1, 2, 3, 4, 5 bases, so 5 m's. This would be my final answer. So looking at this, I can, instead of having to write all of this out, I can just do a shortcut. So my exponents, I have 3 and 2, and then I have a 5. So I can make a shortcut knowing that if I have the same base, all I have to do is add the exponents. So an example of this would be if I have v to the 4th times v to the 5th, I can simplify that down knowing that I have my exponents of 4 plus 5, so that would be v to the 9th. This is also going to work with bases that are not exponents, or sorry, not variables, but actual real numbers. So if I have 2 to the 2nd power times 2 to the 6th power, I know that I can still add my exponents, so I would still have a base of 2. My exponents, if I added them, they would be 8. And then I would go ahead and simplify what 2 to the 8th power would be, which it's super early in the morning, so I'm not even thinking straight right now. But I would go ahead and multiply, I would put that into my calculator and figure out what that answer would be. All right, going on to the next one. The next one I'm going to talk about is the quotient of powers. So quotient, you should recognize, is a fancy word to represent the answer of a division problem. So this is found when I have a base divided by the same base with exponents on them. So it has a fraction bar to represent the division. Very, very seldomly you will have a division sign, so you'll most likely just have it as a fraction bar. So when I look at this, I'm going to have 9 m's on top once I expand them out. 2, 3, 4, 5, 6, 7, 8, 9. I'm going to have 6 m's on the bottom. And then once we have things in the numerator and then in the denominator that match, we can actually cancel them out. So this m is going to cancel out with this m. And I'm just going to go down the line, because when I have the same thing divided by the same thing on the bottom, they would just turn into 1. So once I've cleared out 6 of them, I'm left with 3 on the top. So my answer would be m to the 3rd power. So when I look at my exponents, I can see how the 9, the 6, and the 3 are related. So I can make a shortcut that if I know that they have the same base, again, that's crucial, they have to have the same base, then I can subtract my exponents. So this is also going to work if I have my base as an actual number. So I could have 4 to the 3rd, 4 to the 2nd. If I subtract them, that would leave 4 to the 1st power. Or just 4, since I don't have to have that 1 as my exponent. So that would be my final answer. Next property I would have is power to power. This is when I have a base with an exponent raised to another exponent on the outside. So what this is saying is that I am taking whatever is inside the parentheses, I'm multiplying it by itself 3 times. So I would have m to the 4th. So here's 1. I would have it again. And then I would have it a 3rd time. So I have 3 sets of m to the 4th. So once I look at all these m's laid out, I can see that I have 12 of them. So I have m to the 12th power. So the shortcut, rather than having to write and expand all of this out, is just knowing that when I have a base with a power to a power, I need to multiply the exponents. So I have to multiply the exponents when I have a power to a power. Okay, next one, the last 2. All right, we're going to do the easiest one first. So if I have a 0 as an exponent, so if I have m to the 0 power, this entire thing, the base and exponent included, would change into a 1. That's it. So if I have 4 to the 0 power, that is still just going to be 1. So anytime that I have a 0 as an exponent, I know that this entire term, base and exponent, would change into just a plain old 1. And then the last one. This last one is most likely the one that people trip up on the most. So if I have m to the negative 3rd power, when I simplify this, it is going to look like this. Now let me explain this. So when I have this base and the exponent, this is like a whole number or a whole term. So technically it is always over 1, right? So when I have a negative exponent, I have to change it to the reciprocal, meaning that I have to change the position in the fraction. So if it's on the top, it's going to move to the bottom. And once it moves to the bottom, then the placeholder of 1 is going to fill in its spot. Now once it moves to the bottom, once it changes the position, the negative sign goes away. So vice versa, if I have, say if I have 2 over v to the negative third. So if I'm looking at this, I can't simplify anything with the 2, but I have a negative exponent in the denominator. Now since this is in the denominator, the reciprocal means that I need to move it back up to the top. So when I move this v to the negative third up to the top, it is going to be now attached to the 2, since the 2 is already on top. And then once I move it, my negative sign goes away. So this would be my final answer once I move my negative exponent.